So when we have a carbonyl group, it will convert into hydroxynitrile in the presence of HCN and KCN. The reaction is a nucleophilic addition reaction. The type is addition and the mechanism is a nucleophilic. How to name? Yes, sure, I will name these compounds. How to name the nitrile group? Another example I'll give of this reaction. Say we have ketone, C double bonded with O, and we have CH2, CH3, and we have CH3. Okay. This is a ketone. To make in terms of because it's a trigonal structure, so I can also write like CH2, CH3, and here also CH3. So what is the name of this ketone? Four carbon atoms are there, and the second is carbonyl group. So for four carbon, we can say it is but. They have a single bond N, and the second carbon is having the carbonyl group, so it is butane 2-on. That's the name of this compound. Now, because we use a mixture of potassium cyanide and the hydrogen cyanide or HCN does not decompose. But what happened? The potassium cyanide will decompose into K plus and Cn minus. This Cn, which is here, and carbon is partial positive and oxygen is partial negative. So this Cn, this will attack on the carbon, try to form a bond with carbon. And the oxygen will take both of these electrons which are involved in the bonding. Oxygen will take both of these electrons. So as a result, what we'll have? The first stage we'll have C. Oxygen is there and a negative charge. We have CH3, we have CH3, and we have Cn. Now, the HCN molecule, the hydrogen cyanide, so this HCN molecule, the Cn will take both of these electrons which are involved in the bonding, and the oxygen will try to form a bond with hydrogen. So oxygen will use these electrons, form a bond with hydrogen, and they will take both of these electrons. So as a result, what we'll have? We'll have COH is there, CH3, CH3 and Cn, plus the Cn molecule which is produced because of the breakdown of HCN. So another Cn is there. And this Cn will again attack on another carbonyl group. Now, how to name a compound? Like how we name this compound? We have, this was CH2, CH3, and this is also CH2, CH3. How we name this compound? So we have C, OH is there, CH3 is there, Cn is there, and this is CH2 and then CH3. First, we select the longest carbon chain and we always include the Cn group, the carbon of the Cn group, because that's a main functional group which will affect the properties. So we include this carbon and the longest chain. So this is our longest chain. So second carbon is having the OH and the second carbon is having a methyl group. So we name in alphabetical order. So second position, we have a hydroxy group. So we call 2-hydroxy. Second position, we have a methyl group. So we call 2-methyl. 4 carbon atoms, 1, 2, 3, 4. So for 4, we will say but because of 4. They have a single bond N. And because of this Cn group, what we called as a nitrile. So it is 2-hydroxy, 2-methyl butane nitrile. Is it clear? This mechanism and the final name of the compound which is formed. So we call that as a hydroxynitriles. The next is, this is a common topic for both a student taking Cambridge and Edexcel, that reaction of the carbonyl with iodine in the presence of alkali. This is also known as the triiodomethane reaction, in which this is the main purpose of this reaction is to identify a methyl group next to carbonyl group. Like if we have a carbonyl group, okay, and next to carbonyl group, if it is a methyl group, then it will be a positive result. But if we have a carbonyl group, if we have a carbonyl group and next to carbonyl, if there is no methyl, like example, if it was CH2 and CH3, and we also have CH2 and CH3, so what will happen? This will not give a positive result, this will give a negative result, like the reaction will not occur. So the triiodomethane reaction is used to identify that if there is a methyl group next to carbonyl, if there is no methyl means CH3, if any CH3 group is there directly attached to carbonyl, it will be a positive result. So in this case, this will not give a positive result, but this will give a positive result. So if you want to test the carbonyl group next to, sorry, methyl group next to carbonyl group, we'll get the positive result for this triiodomethane reaction. So how it is done, we use iodine and sodium hydroxide and we warm gently, like we gently warm. So the product will be triiodomethane, which is also a yellow crystals precipitate, and they have an antiseptic smell. So there is a distinctive smell, and the yellow PPT will form. This confirms that there's a methyl group next to carbonyl group. You don't have to learn these equations. You don't have to memorize this equation. You have to learn only the observation and the result. So, for example, if I say I have a compound CH3, C double bonded with O, CH2 and CH3. If I add iodine and the sodium hydroxide, will it give a positive result or a negative? This compound, which is butane 2-on, what will the result, positive or negative? So it will give a positive result. Why it will give a positive result? Because next to carbonyl group, there is a methyl group. So this will give a positive result. And it is not only for carbonyl, because sometimes what happens if we have an alcohol, the alcohol can also be oxidized and then the result can occur. So if we were having, let's say we were having an alcohol, a secondary alcohol was there. So CH3, CH2, COH was there, H and then CH3. And the question is, will it give a positive or a negative result with iodine and the sodium hydroxide? So what will happen, because alcohols can be oxidized. So if this alcohol first oxidized because of the medium, so what it will form, the product will be CH3, CH2, C. This H and OH will be removed, like two hydrogen will be removed. So C double bonded with O and CH3. And then because the triiodomethane reaction happen or occur, so because next to carbonyl group there is a methyl group, so this will also give a positive result, or we can say this will also give a positive result. So sometimes they don't give us the carbonyl group, they give you an alcohol. So alcohol, because it can easily be oxidized, so it may result in a formation of aldehyde or a ketone. But that aldehyde or a ketone which is formed, if it's a methyl group next to that, it will be a positive result. So even some alcohols give a positive result because it can be converted into aldehyde or a ketone, which has having a methyl group next to carbonyl group. If I say we have an alcohol, CH3, CH2, CHOH, CH2, CH3. This will give a positive result or a negative result with triiodomethane. Means will it form a triiodomethane? If we add aqueous alkaline solution and the iodine, so this will be a negative result. Why? Because this alcohol will be oxidized into ketone, and that ketone does not have a carbonyl group, does not have a methyl group next to carbonyl group. So there is a carbonyl, but there is no methyl next to that, so it will give a negative result. So triiodomethane reaction is known, it's also known as the iodoform test, which is used to find a methyl group next to carbonyl. Is it clear, this one? So you don't have to learn the equation for this, but you have to identify whether the result will be positive or negative. Same thing, 2,4-dinitrophenyl hydrazine. Again, you don't have to memorize the formula for this or the reaction. You just have to learn that 2,4-dinitrophenyl hydrazine, what will happen? It is also used to test the presence of a carbonyl group, and it worked positive with both aldehyde and a ketone. So what will happen when we use 2,4-dinitrophenyl hydrazine? It will combine with an aldehyde or a ketone, and it will form a precipitate, orange precipitate. And these orange precipitate, when we work out the melting point of these precipitate, we can identify which specific aldehyde or a ketone is present. This is a structure of 2,4-dinitrophenyl hydrazine. This is a structure. You don't have to learn this structure. So what actually happened, like in this reaction, the two hydrogen which are attached with nitrogen, and we have oxygen which is bonded with a carbon. So hydrogen and oxygen are removed, so it will form H2O. And this nitrogen will combine or form a bond with the carbon. As you can see here, like this is a 2,4-dinitrophenyl hydrazine, and the two hydrogen from here and oxygen from here are removed, and there will be a bond between the carbon and the nitrogen. And this formation of the bond result in the precipitate, which is orange precipitate. And we work out the melting point of these precipitate. Different aldehydes or a ketone, they have a different melting point. So using those melting point, we can identify what specific aldehyde or a ketone is present. Then we have carboxylic acid. The carboxylic acid, they are a weak acid, which is C double bonded with O, and OH group is there. And we say acids are proton donors. So when we dissolve, it will donate proton or give proton. So H plus ion will be lost. And the acetate ion, if it is an ethanoic acid, acetate ion is there. And these acids can form a hydrogen bond with water. That's why they are water soluble. The strength of an acid, look, the carboxylic acid may contain a carbon chain, may have hydrogens only, or may have a halogen. So what does it mean? How it will affect the acidity? If we have a carboxylic acid C double bonded with O and OH, and it is surrounded by the carbon chain. This carbon, like carbon atom, they have the approximately same tendency to attract the electron or to pull the electron. So when acid acid dissociate, it will dissociate into what? It was CH3, CH2, C double bonded with O and OH. This was an acid. So when it dissociate, it will dissociate into CH3, CH2, C double bonded with O and O negative, and there will be H positive. So as increasing a chain length pushes the electron density on this side, because the carbon does not have like tendency to pull that electron. So most of this electron density or most of the electrons are shifted on this side, like which will make it more negative, because it's like the carbonyl groups or alkyl groups are electron releasing group. Like when we say electron releasing, it means like if you compare their tendency to pull electron with other atoms, they have a very weak tendency to pull the electron. So it's like they're pushing the electron away from them. So as a result, electrons are shifted more toward this C double bonded with O. So as a result, when this is more negative, this hydrogen can come back to this group, and as a result, it will form CH3, CH2, C double bonded with O and OH back again. And the definition of acids are proton donors. Like, to be a strong acid, it should donate this proton, like it should give this proton. But when it gives this proton, the carbonyl group pushes the electron density more on this C double bonded with O, so it returned back. So that's why we say that these acids, such as carboxylic acid, methanoic, ethanoic, propanoic, these acids are weak acids. Is it clear? The concept why they are weak acid? So what actually happen is, like, if we have CH3, CH2, CH2, C double bonded with O and OH, acids are proton donors. So they donate this proton, they give this proton. But when CH3, CH2, CH2, C double bonded with O and negative, and H is positive, but because of this carbon chain, the electron density or most of the electron cloud is here, like more negative. So as a result, this hydrogen is returned back, attracted more. As a result, they turn back into a molecule. That's why carboxylic acids are known as weak acid. So there will be a reverse sign, yeah, reverse reaction, because what will happen? It donate proton, but because of the electron density shifted, then it returned back and form a molecule. That's why hydrogen returned back, because when the hydrogen is lost, these alkyl groups or the carbon chain is an electron releasing group. Their electron shifted more toward this side, so this will become more negative. As it becomes more negative, the hydrogen is attracted back and form the molecule. That's why carboxylic acid is weak, are known as the weak acids. Is it clear, this one? Okay. Then we have, anyone is having a doubt related to the acidity of the carboxylic acid? No doubt? Okay. So we have a method of preparing the carboxylic acid, how we can prepare them. We discuss in the primary alcohol, if it is oxidized, it will first oxidize to aldehyde, and our aldehyde will be oxidized to a carboxylic acid. We use oxidizing agents such as potassium dichromate 6 in the presence of sulfuric acid, and it is heat under reflux. An oxidation of an aldehyde, if we have an aldehyde, we can also oxidize aldehyde. That will also result in a formation of carboxylic acid. Hydrolysis of the nitrile group. This is not for a student taking at Excel, only for student, Cambridge student, you have to learn. When we use hydrolysis, means when we break down the substance by the help of water, we call hydrolysis. So if we have a nitrile group, like example CH3, CH2, C triple bonded with N, and we do acid hydrolysis, like acid hydrolysis means like H plus ion is there, and hydrolysis means water is a reactant. That's called hydrolysis. So as a result, what will happen? This nitrile group will form a carboxylic acid, plus it will form ammonium ion. So this nitrile group will turn into carboxylic acid. This is called acid hydrolysis of the nitriles, which result in a formation of carboxylic acid. So we can produce the carboxylic acid by oxidation of aldehyde, by oxidation of primary alcohol, or by hydrolysis of the nitrile. Then the reactions of the carboxylic acid can be reduced to alcohol. If you have a carboxylic acid and we use a reducing agent, lithium tetrahydroaluminate, and is a strong reducing agent. So if we use in a dry ether at room temperature and pressure, the reaction is a reduction reaction, and the role of this reagent, it's a reducing agent. So carboxylic acid will reduce directly to primary alcohol. And the other reactions are same, like when acid react with a metal, it will give salt and hydrogen. Acid react with a base, it will give salt and water. And acid react with a metal carbonate, it will give salt, water, and carbon dioxide. So reaction of a carboxylic acid with phosphorus pentchloride, this is actually a reaction which is used to test the presence of OH group. It will work with both alcohols, like we did for alcohol. If you remember, if we were having an alcohol and we add PCl5, so what was the result? Like this OH will be replaced by one of the chlorine, so it will form halogenoalkane plus the hydrogen combined with Cl, so it will give HCl, and then phosphorus with oxygen and 3 chlorine, so POCl3. Same thing, if we have a carboxylic acid, same way the reaction occur. So if you have a carboxylic acid, C double bonded with O and OH, and we add PCl5. So chlorine will take position of the hydrogen, OH, I mean, so it will become RCOCl. Then hydrogen combined with another chlorine, so it will become HCl, and then it will be POCl3. So hydrogen chloride or hydrogen halide, it will always result in a formation of misty fumes. So we'll observe a misty fumes because of the production of HCl. Is it clear? Any doubt in this? So if the observations are similar, how we can distinguish between alcohol and the carboxylic acid? So this is only a test to check the presence of OH. If you want to identify whether it is an acid, if you want to identify whether it's an acid, so we can add a metal carbonate. If we add a metal carbonate with acid, it will give fizz, bubbles, effervescence. But with alcohol, there will be no visible change. That's how we can distinguish between the two compounds. Then esterification, the formation of an ester, how esters are formed. The carboxylic reactions, in detail carboxylic reactions are not for Edexcel students. It's just you should know what is a carboxylic acid and how we can distinguish carboxylic acid. That's it. Not the reaction of carboxylic acid, and the production is not part for you. In AS, it's in A2 for the Edexcel students. Esterification, formation of an ester, how esters are formed when alcohol react with a carboxylic acid. This will result in a formation of ester and water. The first name of the ester is always from alcohol, and the second name is from the carboxylic acid. Like if you were having methanol mixed with ethanoic acid, this will result in a formation of methyl ethanoid plus water. But this reaction is a reversible reaction, like alcohol and carboxylic acid can form ester, and this ester can break down. We call reverse reaction as hydrolysis. So it will be a hydrolysis of an ester, result in a formation of alcohol and carboxylic acid. The first name of ester is always from alcohol, and the second name is from the carboxylic acid. And the journal naming, like it will be dash YL dash NO8. So this is always from the alcohol, and this is always from the carboxylic, like methyl ethanoic. If we were having an acid, like if you change the acid, we were having butanol, and it was reacting with ethanoic acid or propanoic acid. So which ester will form? The first name is always from alcohol. So it will be butyl, and the second is from the carboxylic acid. So it will be propanoid. So butyl propanoid. So first name is always from alcohol, and the second name is from the carboxylic acid. Is it clear, this concept of formation of ester, and the reverse is known as the hydrolysis? We use sulfuric acid as a catalyst for this reaction. So this is about the carboxylic. Now we have a synthetic routes, how we can proceed